Hello everyone. Welcome back to the stream. Today is 17th of April, and we're gonna continue from yesterday's stream. Today we'll focus on two things. That is, we're gonna tune the reward function so that we can incentivize the agent to attack. So I've pretty much already done a bulk of the work for this one. And then second thing, I'm gonna try to improve the simulation speed because now it's taking very long to do training. So that's something I want to improve on so that we can get our result faster. Right. So yesterday we left off, I think, on 197, which is doing not too bad, right? So we did the normalizing the input. It wasn't really, groundbreaking. We're still behind our previous baseline, which is, I think, 167. You can see 167, it's the same color. Let me quickly fix that. You can see here 167 still has a better result. It's winning more games. So 0.5 means we are winning about 75% of the game, I think. Whereas 0 means we are winning half of the game. So it's not doing particularly well. So I realized that by analyzing the replay, I realized one thing that is not going well for 197. That is, although we have a lot of ships, the agent wasn't really like attacking. So it's kind of like we're going to a situation where the game continues until 400 turns, and then we have a lot of ships, but we didn't eliminate the enemy, right? So I think that's the story in most of these games, I realized. So like, for example, this one, you can see here we have a lot of ships, but we're not winning, right? And we also have very little core. So I guess that's where, this kind of problems comes in. I also, in this case, you can see we have a lot of ships, and this one we actually won, but we're not like eliminating the enemy. So it's kind of, it really depends on how much core do we have at the end. So 2000 core at the end without eliminating enemy is pretty bad. So this one we got lucky. Actually, we shouldn't have even won this one. So that's a problem with 197, right? So the encoding actually worked, but we were just not attacking enough. Not too sure why it didn't beat the previous baseline, but that's the one problem I realized. So I think earlier today I managed to do some experiment to kind of encourage the agent to kind of attack more, right? So I encoded something. I encoded the ship count diff, right? So I think this was something I already was working on in the previous stream. So I encoded the ship count diff to encourage it to kind of like take fights, but that didn't really work very well. So that was 197. So today I tried two more things. I think I tried to in 199 I tried to kind of adjust the reward and domain mapping function so that instead of mapping from 500 negative 500 to negative 1 I map 1000 so that it can kind of accommodate more scenarios. I also kept the reward to 0.2 and negative 0.2. Previously it was just 0.1, so it wasn't very significant. So that was 199. If you look at 199, it was actually like slightly doing better, but still it was kind of going down a little bit. So for 199, the problem is more obvious. So I think in 199 we had a lot of ships towards the end, but we're still not winning. So it's like, so there's something else that is wrong, right? We had a lot of ships towards the end of the game in many of these games, but we didn't actually win. So for example, this one. Okay, this one we again got lucky with only 1000 core, but we had like 1000 ships, but we didn't win, right? So this means that it's not heavily disincentivized to attack. I think the reason is that once we attack, we actually kind of lose the ship count, if you think about it that way. What we gain is the shipyard, right? So we lose a bit of ship count and then we get the shipyard. And it's not really incentivized to do it because you lose ship count, enemy lose ship count, your reward stays the same because it's the ship count difference. So I added another encoding and reward, which is encode the shipyard diff, right? So this is gonna change a lot of things. So basically, once I have the shipyard difference between me and the enemy, attack becomes incentivized. So how it works is basically when you attack, there's a very high chance of you taking over the enemy shipyard, right? So essentially, you just flip the switch. So you get one more shipyard, enemy lose one shipyard. So the shipyard difference is increased by 2, which is quite significant boost in terms of reward function. So that's what I did earlier today. So I added a ship count difference. This is also normalized by the 50 50 ships, right? So this is normalized like this. So we have 1000 here and 20 here. So it's kind of normalized. So it's mapped from -20 to 20 to -1 to 1. And then the maximum we can map is 2 and -2. So that means we'll take care of a range from -40, means we have 40 less shipyards than enemy, to all the way to +40, which means we have 40 more shipyards than the enemy, right? So this actually allows you to kind of incentivize. I was hoping it would incentivize attack, and it seems like it's doing quite well. So I've been running this model for the past few hours, which is the 201. And so far, I would say it's the best model I've gotten so far since like 1 month ago I started to work on this competition, the Core 2022 beta. I think this is the best model I've gotten so far. So there's a few things to note here. First is the Q value is going up very smoothly, and the loss is going down every time the Q value stabilizes, which is correct. And the result is very good. So despite a dropping epsilon, our result is still going up. So this means it's very, very good, consistently learning new things. And I added an additional logging here to record early wins. So early win means we won before 400 rounds. So basically we won by elimination. I think this is what I want to encourage the agent to do more. Because I want to incentivize the attack style. I think that's the dominant strategy over just mining. So it's doing really, really well. It's gotten until I think here is about 0.31, which means I think we're winning definitely more than 50%. I would say about 60 to 70% of the games, right? So far it's the best. If we compare with the previous baseline we got before we change our state encoding. Okay, so it's still not there yet, but it's pretty close. Yeah, it's pretty close, I guess. So it really depends on how it would turn out later. One interesting to note is, like, you can see here the reward is actually less. That's because we're actually ending the game early, right? If you end the game early, you actually get less reward. So that's actually a positive thing, that we're getting less reward than the previous baseline. That means we're actually performing better by ending the game early and winning the game early, right? So I think 201 is the best we've gotten so far, like after we switch the encoding. I'm definitely gonna keep the encoding because that's just I think more information to work with. So So I'm gonna keep that, and this is probably gonna be my next baseline. So that's on the attack part. So we can actually look at some of these logs to see how it's doing. So for example, this one I think is the one that I'm running right now. So this 1666, you can see we finished the game at turn 382, which is a good thing. So we actually finished the game early with a lot of ships. You can see here we have the ship difference and shipyard difference, and both of them are very high. So they are capped at 0.2. So ship, in terms of ship, we are like overwhelmingly more, and shipyard we're also overwhelmingly more because we are basically eliminate the enemy, and there's a lot of attack towards the end, which is the correct behavior we want to encourage. So this is a perfect game, ideal game for us, right? This one again, not so ideal because we didn't win by elimination, but it's pretty close, I think. Of course, there are also games where we didn't manage to outnumber the enemies. For example, this one, which is fine. I guess this one we still win by a number of cores, which is kind of like whatever. I don't really care. Right. So you can see here it's still sometimes not really prioritizing attack. For example, this case, I guess this case we didn't have the a lot of advantage. That's why I think the agent prioritized building ships over attacking, which is fair. I think if you don't have overwhelming advantage, you shouldn't be attacking. Right? This is kind of interesting. Yeah, so far I'm pretty happy with how this model has been working. I would hope it to be more, a little bit more aggressive, like in this case, but I guess it's still trying to learn. Right? So I wouldn't really change that. As you can see now, the training process has become quite slow. It's actually very, very slow. So I think today I'm gonna focus on just making this process like faster, right? In general. So that's what I'm gonna do. I'm gonna leave this one, continue training, and I'm gonna create a new work tree from Git and then work on some of the optimization thing to make the simulation faster. And maybe also make the training process faster if I can. I doubt I can make the training process faster, apart from switching to my PC. So let's try. I think because this is gonna be my baseline anyway, so I'm just gonna commit this. So this is gonna be 201. Right. Oh yeah, I forgot to mention. Actually, there was a 200 which we encoded the ship diff, but it didn't really work because we were trying to attack and we didn't have enough ships in the shipyard. So I added another change, which is to allow it to attack with more ship sizes. This is kind of a limitation of our current setup because we don't know exactly what action it take. So I kind of have to hard code some attack sizes so that we know exactly what we did. So for example, here I hard coded attack sizes to be like 55, 100, and 99. So if we get a value that is within one of these three, then I know it's attack. So it's kind of hacking around the Kaggle environment CLI a bit because we wouldn't know from the output what action exactly did we take, right? So I have to kind of encode some special values to tell us, whether it was a mining or it's attack or something else, right? So that's a little bit of a hack to get around this Kaggle environment. But anyway, since I did that, I think the attack was very effective. So I'm gonna call this 201 encode and more attack sizes. Right? So I think this one is doing this is a good run. All right, so I think this is gonna be our new baseline after 1 day of work. I'm gonna create a new work tree. Oh, in fact, we can I guess we can use back the old work tree because I don't need that anymore. So let's just go back to the old work tree, I guess. This is the old one. Okay, this one, we don't care about this. Oh, no, it's quite laggy. I will check out this branch. Okay, I can't check that out. Which is interesting, so I couldn't do that. Okay, interesting. I didn't know Gittree has this limitation. So what I'm gonna do is create a new branch called optimization, simulation optimization. I'm just trying to optimize simulation, and I'm gonna switch back to the state D, and I'm gonna check out the simulation optimization in the old branch. Right, so now my old branch is running the new code. Yeah, correct. So this is my new branch. Sorry, my new branch. And we're gonna try to do some work here to kind of okay, it's not reading the files correctly. You know what? Let me just reopen this. I think this is too much for the VS Code to handle. Just gonna close this and reopen it. Hopefully I didn't screw up anything. Hopefully I didn't screw up my training process. Yeah, it's okay. So this one is still running. Good. Okay, I think I just had my. Okay. This one we can also close. All right. Let me open this again. Restart to apply the latest update. Okay, it's like updating every single day or something. Just a little bit too much for me. All right. Let's see. We're on the correct branch. We're on the correct branch. So this is gonna be our branch to kind of simulate, to make the simulation faster while we continue to train this, right? So I've been reading how to do profiling on Node.js. I think a easy way is to generate a CPU profile file. And the way you do it is to pass the CPU prof command flag. So that's what I'm gonna do here. So I'm just gonna run a game here. I don't really care like what model you use. Doesn't really matter. I just want to run a game and then like kind of see where the bottleneck is. So I think I do have some model here. Let me check. I have a model 173 here. I also have 9999. I guess I can use the 9999. Doesn't really matter which one I use, I think. So I'm just gonna create a new command to do the to kind of run the simulation. Okay, so that's a bit of a problem here. We're running via a Kaggle environment, right? So it's kind of it's a little bit problematic because we cannot control how it runs our own code. So I think I'm gonna have to make some changes in the main pie. We're gonna change here. So execute a child process. Is there a flag? Args, right? A sequence of command arguments. So that's good. So we can probably add another argument here to do the CPU profiling. So hopefully this will allow us to profile the these spots, right? So let's try to do it here. Notice I'm running this in the other folder. So this is where we're still training. This is a separate worksheet, so we're not affecting the training process at all. I mean, theoretically, it shouldn't affect. So here's what I'm gonna do. I'm gonna run a command to let the agent play against the computer. So I'm gonna run npm cw, and I'm in the wrong directory. Hopefully this will give us a CPU profile file. Okay, so it's immediately died, which is a little bit problematic. Thing flatten to have shape, blah blah blah. Okay. Okay, I see. Because I'm running the new code, so it cannot actually use the old thing. I'm gonna have to delete this one. Yeah, I'm gonna have to delete that one and then rerun this. The model architecture basically changed, so didn't work. This is gonna be a run where we initialize our models. It's gonna be a slightly different one from how it usually runs. But we can take a look first anyway. Let's see if we got our CPU profile here. And okay, I don't see a CPU profile here. I don't see a CPU profile here. Let me do a check. So it's supposed to be running watch 2 means it's running main and minor. So main is the one here, which is running CPU prof. Oh, is my node version too low? Oh, it's 16. So this is not working apparently. Specify the directory is placed in the current working directory. It's placed in the current working directory. Maybe it exited in with the wrong exit code. Could that be the reason why it's not outputting it? Not 100% sure. Okay, let's try to run it again. Okay, let me just open this and check. Okay, this doesn't have it. dist. Yeah, it's not here. Okay, so this is gonna be a little bit more problematic, right? It's a little bit more problematic. I didn't actually generate the file that we want. Configuration raw path. What is the raw path? Java main. What the hell is JS agent? This Lux AI. Okay. Okay, this is also Lux AI. Okay. Wait, am I modifying the wrong file? I'm not modifying the wrong. This is the correct file. So probably something to do with the exit code, right? When the exit code is not 0, it doesn't really output the file that we want. So we kind of have to try another way to profile this, I guess. So let's see. I think there's another way to do profiling. This one. This one. Let's see if this one works. I doubt this would work, but we can try. Okay. Oh, I saw there is a V profile here. Okay, that's good. We got a profile here. So I guess that the other one didn't work, but this one worked. So I think this one I'm supposed to process it. Let me see how do I process this. Okay, so it's just like that. All right. Okay, so this is okay. So I need to pipe this somewhere. A profile.txt. All right, let's take a look at this file. Okay, I guess this is not as good as the CPU profile, but I guess we'll take this. Okay, so share libraries, JavaScript, C++, file handler do shutdown. Okay. Okay, interesting. Ticks total mostly in C++. File system handle shutdown. Interesting. Interesting. Bottom up. Oh, okay. So this is the wrapper, right? Okay, let's see how can we make sense of this. So that's loading the modules. It takes a lot of time to load the modules. Kernel. Okay, I think most is here. This is just loading a module. I don't think I can avoid this. Unless I do some funny tricks to put them together. Which we could actually. We could actually use some kind of webpack to put them together. So that will make things faster. All this still is pretty much still required and stuff like that. Okay, I can see. Okay, maybe I'll just look at the JavaScript. Takes get ship count diff. I think get ship count diff 25. Not really like a lot of them. Get all points on. Yeah, you can see the most of the ticks are not in JavaScript actually. It's in C++, right? And the C++ is mostly all these random things. So I guess these are all actually kind of okay. So it's spending a lot of time loading the modules, which is interesting. I didn't think loading modules would take such a long time. So maybe it's worth it to optimize how it loads the modules, right? Instead of trying to like load them, I should just concatenate them, right? So maybe it's not the problem of the code, it's just how Node.js takes very long to load the modules. Right, clearly from here it's spending a lot of time just loading the modules. It's like crazy amount of time. Right, all these are just like loading modules. So I'm gonna try to look for some solution to like pack them. Just package files, modules into one file. I don't know. Let's browserify. Okay, I can use Webpack to do it. ESBuild. ESBuild is a new tool, right? And let's see if we can actually do this. Yes, build bundle output file. Building for node, bundle platform target, 10. Bundle platform node external. Want to build dependencies. Okay, let's see if this works. I think this might be what I'm looking for here. Right, so this is gonna be installed here. I think we're using npm, so let's use npm here. Okay, so Can check the version. Sure, let's bundle the node. So I'm gonna do this slash dist, sorry, dot slash dist slash bot.js and dash dash platform. Go to node. Do I need to specify the target? I guess, sure. Oh, 16, yes. Let's see. Yes, build not found. Okay, cool. Okay, it's fine. I think I know why it cannot find. So I'm just gonna do dot slash node modules dot bin. Oh, what's happening? What just happened? Oh, okay. I'm supposed to provide an out file. Okay, okay, okay. Equals to I guess I can just put it here. Out.js. Okay, it's done. Oh, that's very fast. Let's take a look at this. It still requires files, right? It still requires files. Still require files. How can I get rid of the require? Okay, so let's delete this. I think this is not what I want. I need to maybe directly do it on bot.ts. Okay, it's even smaller. That doesn't look right. Okay, so it's not bundling the files together. It's not bundling the files together. Okay, I need to look at how to do this. Bundle dependencies. It doesn't seem to bundle dependencies. Hmm. It doesn't seem to do what I wanted to do. Bundle node dependencies. Interesting. I think the documentation assumes that it will undo it together, but I don't really see. Maybe I'm doing something wrong. Not supported yet. 12. It's still importing, right? Am I missing something here? CGS. It's the same. Remove the platform. Environment was set to ES5 here. Warming led to configure environment is not yet supported. Okay. Okay, let's change that. ES6. Okay. I don't think that did what I wanted to do. Still importing. How can I let it not import? Okay, I have to just check some of the pack. Okay, maybe I need to use the bundle. Maybe that's what I'm missing. Okay, I see. I was missing the bundle. I think. Okay, let's try with the bundle. I cannot require what? Okay. I probably should mark them as external, but interesting. Utilities. Can I ignore them? Yeah, I forgot to add a bundle. That's why it wasn't external. Okay. Let's look as external. Map box. A map box. Okay, I guess I can mark this as external. Externals. External dot slash module star. Okay, that was very fast. That was really fast. I think this might be it. This might be the run. Let's see. Okay. Okay, it's a very big file, but it might just be what we need. It might just be what we need, right? Let's see, this is pretty exciting. I didn't know I could do tricks like this. Hopefully it's gonna make things a lot faster. A lot more faster. A lot faster. So I'm gonna do ./out.js run npm cw. Okay, it died. Okay. Let's see what went wrong here. Oh, pre-binding does not exist. Oh no. Okay, we shouldn't have ignored that, I guess. Holy shit, I didn't realize we actually need that. Alright, alright. Seems like I need all of this. Which is really weird, but sure. I will just manually install all of you. A little bit weird. I don't think I need that. I think I always have problem with those packages for some strange reasons. Alright, I'm gonna make this a build command. So instead of compile, we now have a build command, which is gonna execute this. Alright, so now we can just run npm build. Okay, 20 megabytes. Okay, npm. Okay, that means that we don't, when we submit, we can also just submit this one file. That's pretty interesting. That's really fast. I didn't expect it to be that fast. Okay, still died. Okay, something is still wrong here. Take a look at this. Trace back. Broken pipe. Blah 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 blah. Okay. Package JSON path does not exist. Find. Can I go to this line? Okay, binding. Starter bot. Package.json does not exist. Why is he trying to find it one level above? Hmm. How can I get rid of this? One level above. It's trying to find it one level above. Okay, so maybe we can put it here. That will solve the problem. I don't know. Let's see if this solves the problem. It's just it's a folder directory issue. Okay, it still dies. Hopefully something else. Okay, interesting. Must declare the following properties, main version in binary. Okay. I guess it doesn't really work. Have to make them. I kind of have to make them external. I think I have to make them external. There's just no other way. Let's see if I can find. This thing, ES build is giving a lot of problems. Okay, never mind. I'll just use this, I guess. Hopefully that will fix the problem. I'm not too sure if they will fix it. I think previously I saw another issue when I do this. Oops, wrong. Build. 81 kilobytes, no. Okay, now it's able to run correctly. Let me remove this too and check out how it works. Oh, it's printing out those things as well. Let me delete them and we can run them later. 2,400 lines. Cool. There's gonna be have some require going on here. It's gonna be some, yeah, some require going on here. Okay. Let's try this. Okay, I didn't know ES build was that fast. Okay, so now it looks like it's a lot faster. Looks like it's a lot faster. All right, we need to, of course, do the other trick is to run a node process of profile new.txt. All right. Let's see. Still mostly in C++. But now, oh wait, this is not the correct thing to look at. Okay, so now actually, yeah, so now I think a lot of the load module has disappeared, or still a lot of load module. So I guess it does help a little bit, at least. It should at least help a little bit, I think. Yeah. Okay. Okay, I still want to make it work. I still want to make it work. Node module build. Yeah. But then I have to switch to the TFJS browser version, I think. It's gonna be tricky to do that, I think. It's gonna be very tricky to do that. Try again. Can I preserve the binary path? Oh, wait. Okay, I guess this might work. I'm gonna exclude these files. And let me try to exclude these files. It's still a lot of... Okay, so those files actually... Okay, now it still runs, which is great. I guess this is a new one. All right, let's take a look at this. We can compare the summaries with the previous ones. Actually, it's more ticks. Let's take a look. 89% in C++. It is 90% C++. This is 89% C++. So it's still mostly C++. Still mostly C++. Kernel backend. Yeah, this one is still taking up 200. Still taking up 200. Okay. Yeah, let's try again. Let's try to be more specific. Let's just include this. Okay, it's about the same. Yeah, at least it still runs. I don't think this is gonna change that much, but let's see. Okay, it doesn't change that much. Still pretty much doing that. Okay, I have to be more smart about this. Unfortunately, this doesn't really work. Have to try something new. So the problem is with loading trying to load that thing. File path, go up, main version name binary. Can I force it to use another path? It's just using this. trying to get the thing. So let's try to do some weird hacks around this, right? So it's trying to look for that file, and I'm actually gonna give that file to it. I'm going to give that file. So gonna be smart about this. Yes, build output. List, right? So I'm gonna put it to yes build output slash list slash out, and I'm gonna try to put that file there. Wait. Maybe I was looking at the wrong thing. Okay, so this is where it is. It's gonna try to look for a textual JSON on this level. So what I'm gonna do is I'm gonna copy paste the thing that it needs to that specific thing. Right, I think this is what it needs. Main, and you have binary here, which is okay, sure. It's trying to go here to find it. Right, so I'm gonna copy it to this is gonna be really weird, but oh, it also has a dist file. Huh, that means I can't use the dist file. I have to use the out. Okay, try this again. I can't have a dist folder here. So this is gonna be our agent thing, and I'm gonna copy paste this whole thing here. And then I'm gonna run this. Okay, still died. Let's see. Oh wait, it's not using that file. Okay. Yeah, it's not using that file. So I'm gonna change the main to use that new file. So it's gonna be this dash alt. Okay. Okay, maybe it worked. Wait, what's happening? Oh, it worked. Oh wow, I didn't expect that to work, but it did work. All right, it actually worked. So let's generate another thing. Oh, but it's super slow though. It's very slow. So maybe it's not worth it to do that. Maybe it was not worth it. Yeah, but it's quite interesting what kind of optimization we can do here. So this is gonna be number 4. Let's analyze this one. I think this one is gonna be better. Oh, we don't have unknown functions anymore because we package everything inside already. Oh my god, it's taking very long. Wait, why is this taking? Okay, it still have unknown functions. Let's see, share library, JavaScript, C++. Okay, still the same, still about the same. So it didn't really help that much, I guess. Why though? Why is it still? Why is it still doing this? It's still doing some compiling work, which is interesting. Okay. So how do we know that our optimization worked? We can run some training to test. Right, we can run some training to test if it worked. So we can remove this. Our training code is gonna invoke that one. And we have a separate agent here, which is different from what's being run on the other side. So we can, I think if we run the training here, we'll be able to see the difference, right? So, okay, let me remove all of this. So previously we were running 201. Okay, still improving, not too bad. It's still going up. 201, so let's call this 202. Yes, build optimization, I guess. So we can run the 202 here. Run equal to 202 npm run train. So I'm expecting this one to run a lot faster. Well, fine, name Jasmine. Okay, this doesn't really work. This doesn't really work. Well, fine, Jasmine. Maybe it's a easy fix. Okay. We might have to delete that thing. Okay, it's starting to run. Not bad, not bad. Let's see if it's indeed much faster. Oh, but we're running two things in parallel, so, and we're streaming, so might not feel that much faster, right? But yeah, it's indeed very slow. Yeah, it's pretty much full CPU now, so we can't really tell whether it's faster or not. But I learned how to use ES build at least. I think that will help us with submitting our code to Kaggle as well. Potentially it's easier to submit. Okay, I think we need to look at the replay to see if we're doing something correctly. Let's check the replay. Should be somewhere here. Load model success. Okay, so this one should be running the main.py, right? I think this one is running the main.py. JSON train, using train this one, and this one is using main.py, and then main.py is using the ES output. Okay, so it is supposed to be using the new thing, right? So the ES out is just a 21 megabyte file. Okay, I can feel that it's probably faster already. I don't know if there's a psychological thing or what. It does feel a little bit faster. I don't know if I should stop this. But we can definitely check something here. Like we can check when it finished the first n number of games, right? So like say 20k. So 20k it took 6 minutes, right? Took 6 minutes for 20k. And then for the new one, okay, my computer is really lagging. Holy shit! I think I'm stressing my computer a little bit too much. We can take a look at 202. Nothing is showing up yet. Oh yeah, because we haven't started training. The bottleneck could also be on the Python side of things, the Kaggle environment. It might take some time to set up the Kaggle environment. Yeah. I'm surprised that after we optimized everything, we still had like some file system stuff going on here. It's a little bit weird. Oh, if we look at this summary, okay, so 1917, 17, 17, 16. I guess it's slightly lower, but in terms of the total, it's still about the same, like 90%. Right? And then in terms of the C++, sorry, bottom up file system. Oh wait, this is a compilation thing. This is a compilation thing. So maybe compare this with that. %, 24%. Not much difference. Not much difference. Not much difference. Context compile function. Oh, we lost a lot of. Oh, no, this is C++ entry point. Contextify compile function. Require. Require loader is still taking up 200 plus. That's really weird. I don't think we're supposed to have that much. Oh, here's all the convolution stuff. Kernel function. So actually, maybe here we can get some clue on what are the things that is taking a long time. Let's get ship count diff and get all points on path. Right. Uh, Crypto, okay. It's a little bit weird. Not too sure what's happening. Okay, so 10K took about 6 minutes. Okay, so that's definitely slower. 20K took 6 minutes. Here, 10K already took 6 minutes. but we're at 100% CPU usage, right? So it might not be accurate. Might not be accurate. So I guess we have to try to run this experiment sometime later to see if it's actually better. But for now, I think I'm gonna let this continue training because it's still going up still. So it's gonna be really interesting to see how well it does, right? I'm gonna continue with the optimization maybe in the next stream. We'll do some more experiment on exactly why it's taking so long to load the modules. But so far this is looking pretty good. You can see we're just basically attacking towards the end and it's doing pretty well. Yeah, it's just interesting. All right, I think that's the end of today's stream. I'll see you guys in the next stream tomorrow. Okay.